Yeah, this is amazing. All right, so seeing that's going to happen.
Hi, Joan. It's Marik here. I will be passing your slides, so just give me the sign, and I'll be happy to do that.
Oh, excellent! Thank you very much. So I understand that we will wait 3 more minutes for the people to join the breakouts. And then there will be an introduction that I understand I have to do, probably based on reading the or 5 time. And I have, but I will try my best. I always feel that you have to cut the most important part of the presentation when you control the time. But anyway, those are the rules, so we will apply them. In my clock, we still have 1.5 minutes. Maybe I can, 27 people. 26, we are losing people, so it's better that we start. So thank you very much for being here into this breakout number 3, interoperability challenges for thematic communities. I'm Joan Masó. It says UAB, that's the Autonomous University of Barcelona, but my research center is not the UAB, actually, it's the CREAF, that's a research center in ecology and applied forestry. But we do much more, like digital maps and map browsers, things like that, remote sensing. Well, and also citizen science, I have to say. But I'm not here to introduce myself. I'm here to introduce the presentations that we are going to have. So Andreas Petzold will tell us about the ENVRI-hub, the platform of the environmental science community in EOSC. Georgios Kakaletris will tell us about the NEANIAS ecosystem, design principles, architecture, and infrastructural resources. Peter Kraker will present about CoVis, a curated knowledge map of seminal works on COVID-19. I wonder what is that COVID-19. I never heard about that. ESCAPE, interoperability of data and services will be done by Mark Allen. And finally, Laura Rodríguez-Navas will tell us, how do I pronounce this? WfExS, software component to enable the use of Crate in EOSC-Life tools collaboratory. That was really a challenge to read, but I believe I managed more or less. And since only have 10 minutes for do those presentations, I believe that's better that we use these 4 extra minutes that we have and we just start. So Andreas, if you are ready, I would like you to start your presentation, please.
Hello, everyone. Andreas speaking. Yes, I'm ready. I think Marike will bring up the slides. Thank you so much. So I will introduce to you the ENVRI-hub, which is the platform of the environmental sciences community in the European Open Science Cloud. I'm working at the Research Center Jülich. From my training, I'm an atmospheric scientist, and I'm also the coordinator of the ENVRI-FAIR project. Next slide, please. in the community of the environmental sciences, you have to think. We combine infrastructures doing atmospheric research, doing research on biodiversity and in terrestrial ecosystems, land-based search on soil and seismology, for instance, and water research. And this all comes together in the ENVRI community. Traditionally, and so far, our current users of the infrastructures, like scientists, industry, society in general, and also citizens, they approach the research infrastructures and their portals, their data portals individually. Or more broad users like the Copernicus Atmosphere Monitoring Service, they have some joint access to data which we provide to them in near real time. This is the situation of today. Next, please. Next slide, please. Thank you. So one task of the ENVRI-hub is that we combine what we call the domains. So all atmospheric infrastructures, all infrastructures in biodiversity and life sciences, ocean research and land sciences together to offer access to users like Copernicus to the whole subdomain. And next slide, please. And the final goal of the ENVRI-hub is to allow all the users, wherever they come from science, industry, society, etc., to get a coordinated access to the whole entity, because you can think about the situation now that if a scientist is searching for data in his domain, he or she knows where to go. But if you are searching for data in another subdomain like CO2 in ocean waters, and you are an atmospheric scientist, you have no idea where you find the data or how they are measured or what their quality is. Our goal is to provide an entry platform where scientists can grab information and access to data for all the different domains for true interdisciplinary research. Next slide, please. Oops. So to serve the various needs, the ENVRI-hub is split up in 3 main components, and this is the what we call the ENVRI knowledge base. This is a resource where IT specialists or users of any kind can gather knowledge, information on the discovery of data, of services and assets, what the community can offer. And we can also will provide information of engineering practices, technologies and knowledge. So to share our solutions to given problems, or to allow external experts to share their knowledge, their solutions to problems. And this is a kind of an interactive exchange component. The center part will be the machine actionable interface, which we call the ENVRI catalog. This will be directly exposed to EOSC. And this will catalog all research infrastructures in the environmental domain, and to allows accessing our data sets via metadata search, and will also serve as an interface to EOSC and to other users. Again, prime example is Copernicus. And for the interoperability case and interdisciplinary showcases, we will have another part on the Jupyter notebooks as virtual research environments to show scientific demonstration cases, to demonstrate what we can achieve in addition to what is possible today by establishing these interoperability. That means to demonstrate the power of additional links and additional use of data. Next slide, please. Technically, so far, as I showed at the end, at the beginning with a short cartoon, we have traditionally the direct contacts of the users to the different research infrastructures, which you see on the left. Next slide, please. Now the ENVRI-hub will step in between with the research catalog, the documentation, and the notebook engine. And next, please. To offer an alternative connection via the ENVRI-hub with a much broader access or search engine. Next, please. And allow a more improved discovery of research infrastructure services across the boundaries of the subdomains. Next, please. And give direct access to the research infrastructure data and service layers. All the data, all the services will be hosted and maintained by the individual research infrastructure. So the ENVRI-hub serves as a broker. And next slide, please. And this broker and platform will also serve to enhance the reuse of data and services and to increase the engagement of the scientific community. Next, please. How is that done? So the idea is to have a central entry, website front end, like it's under development now. And this will manage the connections to the knowledge base, to the catalog, to the training, what is a very broad field of activity in our sense, and also to science demonstrators for the different demonstration cases. And also an interface to allow Sparkle federated queries to the research infrastructures, to the individual research infrastructures. Next slide, please. And in the background, which you do not see as a layer, we will manage that by various technologies. So we have an API layer, which handles the connection to the catalog and to the individual ENVRI-hub API and to the training catalog, the ENVRI catalog. We will have the Sparkle client to manage the queries to the individual research infrastructures. And we have the Jupyter notebooks hosted by the RIs on the demonstrators and another Jupyter notebook host for the virtual research environment and services provided by the entire community. And next slide, please. It's my last one. And so at the end, and this is a graphic presentation we prepared for the EOSC Future project. So we will provide, it's now a buzzword, another EOSC buzzword, key exploitable results from our community. And this will be the knowledge base, the service catalog, single access to the individual research infrastructures, our science demonstrators, the training platform, and the virtual research environments. These are the results from ENVRI-FAIR, which you can access as a user, and this will all handled by the ENVRI-hub under the roof of the ENVRI-hub. Thank you very much.
Thank you, perfectly on time. We have 3 more minutes if we want to have questions to Andreas. Do we have anything on the chat? Not really, I believe. Okay, I have a question for you. I mean, in terms of exposing all these services into the catalog and the marketplace of EOSC, are you thinking on a single service? This is going to be a service for each of those things you mentioned, one for the catalog, one for the knowledge base, one for the Jupyter notebooks, or there will be one entry for each of the ENVRI members? How do you see the connection to the EOSC community?
The connection is more thought in a federated way. So that is why we are strongly interested, for instance, in the task force on AAI, because we want to manage that centrally, that all the people can log on to the different research infrastructures via the ENVRI-hub. So the ENVRI-hub should serve as a centralized platform, and this will be exposed to the EOSC, and then we have all the details in the background handled like that. That's our ambition, and for that we need to establish centralized services like AAI, and also to establish interoperability standards. Actually, we work on a coordinated metadata representation to allow structured search and things like that. So we see that the ENVRI-hub will contribute a lot to the EOSC exchange level, which will help us to build the common background, and then we can operate our dedicated services.
Mm-hmm. Thank you for that. There are 3 questions now on the chat. Bert, do you want to verbalize yours?
Yes, I had a short question for Andreas. Can you hear me?
Yes.
Yes.
Yes. Hi, I'm Bert Meerman from the GoFair Foundation. I have a question because first of all, excellent presentation, and what I can see is that what you're trying to do with the ENVRI-hub is basically to a large extent what the EOSC is trying to do. So my question is, what else is needed if you get this to work in a relatively short time frame? What else is then to be done? Because my feeling is that for 80–90%, this is what the EOSC is trying to do or was trying to do.
Thank you for putting the ambition so high. So we try to do that for a certain community, not for the very broad users, but for the community of the environmental sciences. And in the running time of the ENVRI-FAIR project, we will only be able to establish a demonstrator with some few cases to start the journey. We cannot finish it. So that means actually we try to build the technical basis with the metadata mapping, with the establishing Sparkle endpoints for the queries, etc.
Yeah.
And in parallel, we build up a front end, and then this will be aligned with the EOSC so that we can expose it. In a way, you are right that we try to do that on a let's say EOSC in small. Our advantage is that the structure of data and services in the environmental sciences are not very similar, but they at least there are some similarities. So we don't have to deal with a broad diversity of digital objects. So that makes life a bit easier for us, I hope. Yeah. And I see you from the GoFair Foundation, for instance. What is a big effort on our side together with you or with your institution is the development of the FAIR implementation profiles as a tool to enhance, first to check or to assess fairness of our partners and to show ways how to improve fairness. And these efforts cannot be done without support from GoFair and other EOSC-centered activities. In that sense, we certainly rely on this very fruitful ecosystem around us.
Yeah, thank you, Andreas. There are a couple of, I will ask you a favor. There are a couple of questions in the chat, so you could try and answer them in text mode. Thank you for that. We have to run to the next presentation. Nevertheless, I have to say, trying also to ask the last presentation that I know the ENVRI-hub or the ENVRI community at least for a while, and I believe it's fair to say that they have been working on the direction exposed today for a lot of time. First doing the first steps, and now with the components that Andreas just presented. So it's natural that they have the capacity because they have been exercising this integration in the network for quite a while. So Georgios Kakaletris, are you ready to do this presentation about the NEANIAS ecosystem?
Yes.
Thank you.
I don't think I can match Andreas' excellent presentation and timing, but I will let's cut it if I go too long. I hope you can hear me. I'm Georgios Kakaletris from CITE. I'm technical manager of the project of NEANIAS, which is one of the projects that is providing EOSC services for thematic sectors. And let's go to the next one. In this particular presentation, I will also speak a little about NEANIAS, and then I will talk about technical things, technical challenges and responses we have in NEANIAS for several topics in interoperability regarding data and services. Let me say that there is an updated version of this presentation that will be shared later on, because this has some typos and some small issues that might mix the reader afterwards. So we will update it. I have already sent one, but it was last minute. So let's go to the next one. NEANIAS project is providing 9 thematic services that, although it was not mandatory from the call, we are targeting to onboard them on EOSC. And those span the 3 sectors of underwater research, atmospheric research, and space research. It's very diverse. Other projects try to focus on something. We work on all those sectors together because our view is different. It's providing the means to facilitate communities onboarding EOSC building business on that. That's why we have 2 business cases established since the beginning of the proposal and more onboarded via open calls. Business cases can energy, atmosphere, climate, and water and space, which are also the research sectors. And here we're trying to go from TRL level 6 to TRL level 8, which means nearly product. Of course, a product has other things like the span of features, etc. Let's not address this in here. Let's focus on our challenges. We have some big infrastructure at hand, mainly from GAR, but also from partners. Not everything is listed here. The overall data size is several more petabytes because it also has space data and things like that. Though our temporary storage for operations and local data is about 20 terabytes will be at the end of the project. The data we work on and we consume is much more. We have a logical architecture which is rather complex. Every box you see here has to interoperate with others, so we have interoperability challenges everywhere. And the tip of the iceberg are the thematic services, which of course they have their challenges, but there are many things underneath that will make this operational in a cloud infrastructure like EOSC, an open science infrastructure. So let's go to the next one. Okay. In NEANIAS, we started the first question that you have when you go to offer EOSC service is what an EOSC service. I think there is no single answer to that. As you can see, EOSC services might be spanning from entire complex ecosystems of applications up to a single service that is offering an endpoint for something. So we had to define some principles for an NEANIAS service, which is the things in gray, and some implementation principles in general for NEANIAS, because not all our services are EOSC services. We have a mix of services that might stay outside, will stay outside EOSC. So we developed this concept that says an NEANIAS EOSC service has to be cloud enabled, scalable and elastic, and has to be able to consume resources going up and down. It has to be aligned to some principles of open science, transparency, usability, and have all the means for that, and also aligned with the FAIR principles. It has to be accountable, which means authentication. We have accounting. It has to be secure. This depends on the service, but we have to protect some data at least there. It has to be operational, otherwise it doesn't go reach EOSC. It has to be TRL server, I think, to be there. So we have all those small things and more than the ones that I list here for the operationality of a service. It has to be aligned with some EOSC technology, although those are not mandatory. We find it a good way, and EOSC is going there to have AI integration with EOSC, monitor integration with EOSC, account integration in the future, and ordering, which is now doesn't feature any integration, but we hope it will. And finally, be integrated in EOSC, which means have a service description, a legal framework definition around it, and be registered in the marketplace. And apart of that, we have some principles that all are surrounding interoperability, because we need portability, we need standard compliance, free and open source software, or at least alternatives of software, in order to avoid vendor lock-ins and unnecessary coupling of services. And we have also another policy, because we're not trying to present one infrastructure for all, but we want to present instruments for all to do their work. We're trying to not mix one partner's work with the others. Everything should not be disrupting the way another service operates. So if this rings a bell, it's about aspect-oriented approaches wherever we can do this, because this is not always feasible. Next slide, please. If we were, because this is not my choice, to pick two challenges, I would, if I was picking one, of course, it would be the thing of authorization and delegation in the very generic prism, under the very generic prism of end-to-end service interoperability. If I was to pick a second one, the second one would be the resolution of data identities into actual data. The first one is about having a service to be able in this ecosystem of years to start at one point and then finish its work and deliver data to the user without having new user interactions in the flow passing through other infrastructures, et cetera, which means we need delegation, authorization, and cross-domain trust relationship, which is something that is everybody's vision, but is not coming. And the other thing is to get my PID and give me my data, not go through web pages to resolve them, to select protocols and all the other things. Of course, there are many, let's go to the next one. There are many, many other things in interoperability, but those would be the two primary ones for us to do our work easier. Here with NEANIAS, we've met a lot of things with respect to interoperability challenges, discovery of data. So we do go and work with interoperable repositories, promoting Zenodo here, but we also have our internal means for sharing data because not all data are published. So we have the similar approach as a solution for sharing data. We have this interoperability with the Zenodo, but we also have our internal WebDAV-based service. We have the challenge of identifying data. And okay, when we go public, we get our DOAs. When we share the metadata, we go through the OA. But otherwise, we have our internal URLs. We have the challenge of describing data as everybody. Currently, we stick to the Zenodo publication API require metadata and optional ones, but we also have our customary descriptors and the provenance records formed by each service by its own in a readable format, but with proprietary assumptions. We'll have the standard challenge with the formats. There we give the standards where we can. However, in some cases, we revert also to XML, JSON, and CSV for non-standardized forms. We don't have a solution for the resolution of PID into data directly, so we got to go to the particular provider to see how we get the data. For accessing the data, we have topic-specific standards mostly, and where there are proprietary APIs, we also engage those. And we have our local storage as well, which is a common denominator for all systems, I would say. We would like to see something solving the interpretation of policies and licensing for data, but we're not there yet. So the question, how will I use the data and what impact will it have ultimately in this kind of particular type of work I'm doing is something quite open for us. Next slide, please. And then, of course, we will have the AAI challenge. There we go with the standards. There is a challenge of service-to-service authentication, where we see several things that are not in EOSC, let's say, architecture, in line with EOSC architecture for security, because there are services that work otherwise. There are very well-known services that work with certificates or public and private key pairs of their own. So those have to go their way, and we have to somehow hide them under the hood. Delegation authorization will go with proprietary solutions and things like that. But then there are challenges also in the operation. How do we share a workload? How do we pass a process to someone else? How we abstract storage in a way that it can be used both by the user, by the service, and by any computer resource, for example. Many small things. I would go to many technical details. I'll go this road, so I leave them out. And just one last slide. I think I have. This is a small list of the standards that are applied now in various areas of the project. We have a lot to do with geospatial data because we have this ATMO and underwater challenges, but also cases. But we also have the space, so other comes from there. The general one from the open science domains, and the generic paradigm that you see on the left and on the right. And that's all from me.
And thank you for that. Just a very short question. The fact that the EOSC is not completely defined, and you know, there is no list of standards that you should comply yet. There are some clues here and there, but it's not complete. Is that a challenge for you?
I don't know. It depends on which area you are considering the standard. Having one single standard for everything, I mean, for here you do that, there you do the other. I don't think it would be a total solution, because there are conflicting standards because of different interests and priorities in several sectors. See, the OGC has so many standards for even for drawing a map, for getting a map. There are reasons for us, for processing data. There are reasons for having alternative standards. Of course, having a list of, let's say, of proposed standards and ways to cross boundaries of domains of authority would be great help. For AAI, we would definitely welcome a single standard. For PIDs, we also would do that. I don't know if it would go for other areas.
Thank you, Gregorios, for that. We need Peter to take the mic and tell us about this COVID-19 that I never heard about. Please indulge us with some knowledge here.
Yes, thank you very much. I hope you can see and hear me now.
You are ready to go. Everything is perfect.
Okay, excellent. Thank you very much. Yes, so thank you for the invitation to present CoVis to you today. I'm the founder and chairman of Open Knowledge Maps, and I want to start off with the motivation for our work. Next slide, please. I think it's very well summed up in this image from Science. So in the coronavirus pandemic, we've seen an explosion of scientific knowledge. More than 200,000 papers are now published on the topic. And that makes it very difficult to get an overview of the area. And once you have it, to then keep it. But it's not just coronavirus research. With between 3 and 8 million papers published each year, discoverability is a huge issue in any discipline. Next slide, please. And this was the starting point for Open Knowledge Maps. We wanted to give a different ability to search and discover scientific knowledge apart from the list-based interfaces that we have at this point. Next slide, please. So we founded a charitable nonprofit organization which is dedicated to dramatically improving the visibility of scientific knowledge for science, but also for all the other stakeholders in society. Next slide, please. And our proposal is example map that knowledge maps have a number of advantages over pure list-based interfaces in that you can see the main areas at a glance. So for example, here it is risk factors, types of diseases and prevention. And you have relevant resources attached to each of these areas so you can get immediately started. Next slide, please. From the theory to the practice, if you go to our website, openknowledgemaps.org, you can create a knowledge map of your own. We have integrated PubMed and based a Bielefeld academic search engine, so you can create a knowledge map in any discipline. And if you then type in the topic that you're interested in, for example, digital education, then we will create a knowledge map for you. Next slide, please. And this will look similar like the example that I just showed you in that the bubbles represent the sub areas, and then you have relevant papers and other resources that are related to each of these areas that you can access by zooming into it. We're developing all of this as an open infrastructure, and as such, we are of course very well fitted within the EOSC. And next slide, please. We have a number of projects. The first one is Tripper, the multilingual discovery platform for the social sciences and humanities, which is an infra-EOSC project coordinated by CNRS from Humanum out of France and is part of Operas. We're also about to start a project as part of the German Volkswagen Foundation Encore towards an open zoomable atlas for innovation science and beyond, where we are collaborating with Free University in Berlin and Wikidata. And we've also conducted a project together with OpenAir, where we've developed a visual project explorer. Next slide, please. But today I'm of course here to tell you about CoVis. And here we teamed up with our partners Refigure in the early days of the pandemic. And we were very happy to receive support from the EOSC-Secretariat for this activity. Next slide, please. In CoVis, we focused especially on the reliable research. As you can imagine, a lot of research was published in a very short amount of time, and many people pivoted to this area without prior knowledge or training. So they had a really hard time to find out what are the seminal papers, what is the research that I actually want to build my research upon. And so we created a knowledge map here. Next slide, please. We focused on biomedical research. So here you can see 9 key areas of biomedical research and then seminal resources related to each of these areas. Once you've identified an area that you're interested in, let's say, for example, therapeutics down on the bottom, then next slide, please. You can zoom into it and you can see the resources that are related to this area. You can also see on the right-hand side that there are curator comments which further contextualize this piece of research within the area. Next slide, please. We've integrated different types of resources, data sets, journal articles, preprints, reviews, and also a resource type called a refigure. Next slide, please. And if you select for refigure, you will get further knowledge synthesis because many research questions cannot be answered by a single paper. So for example, in this question, whether hydroxychloroquine is actually an effective drug, there are multiple studies and they need to be synthesized, and that happens in the refigures. Next slide, please. So if you click on link in the previous screen, you will get to the refigure platform, and you can see here 5 trials that evaluate hydroxychloroquine and give a large picture, a knowledge synthesis of what we know on this subject. And we wanted to bring this up because we think that these kind of links between the infrastructures are really important, and it's important that they are meaningful, right? So we've seen with CoVis that it's now being used as a training tool to train new COVID-19 researchers in biomedical labs because they can get this kind of bigger picture, but then they can also go down very deep into the knowledge synthesis of several papers. And I think in the EOSC we have hubs, but we need to understand how these hubs now will interact. And that's where I personally also see these links as a very valuable and useful tool. But of course, this was also to be designed, and we have to have a useful user journey through the different hubs. This is also something that we live in the Triple project, where we have a core platform and then innovative services which are more or less integrated with this core. And in Open Knowledge Maps, we're also developing a very exciting new model, which is called the custom services model, which will enable you to integrate visual discovery components in your platforms, in your organizations, and there are very low requirements to do so. So it's kind of instant overview over the resources that you have. More on that in the LIBA conference, actually, next week. But for now, I would like to go to the next slide and just mention that in this case, the data source is actually not a standard API, but we rather integrated a spreadsheet because all the content in CoVis is curated. And next slide, please. For this, we have a dedicated curation team, which is based mostly in Massachusetts in the US, and the design and development, which was taken over by Open Knowledge Maps. And of course, we invite everyone in the community to become a curator and to contribute to this knowledge resource. Yes. Next slide, please. All of the services that we develop in Open Knowledge Maps are free and open. That also includes our training materials and activities, our visualization software, and our community support and engagement programs. And if you, next slide, please, want to help sustain this infrastructure, then please join these 11 prestigious organizations who've already become supporting members of Open Knowledge Maps. We invite you all to co-create our platform together with us, and especially this custom services model that we're developing at the moment. Next slide, please. With that, I would like to thank you for your attention, and I'm happy to answer any questions that you may have.
Thank you. That was perfectly on time. This presentation is different because I believe you are telling us about one particular service that could aggregate many things in EOSC. Do you believe this is also useful for data? I mean, you have talked a lot about publications, about knowledge, but what about the data?
Yeah, absolutely. We already enable overviews of data as well. So our main data source in the background is BASE, and BASE aggregates over 5 million data sets already. So you can actually on our website already create an overview of the data. And I think what we did in CoVis was to combine data sets with the literature and other resources. And I think that's where we want to also go in the future, right? To really contextualize the data sets with the resources that are related to it.
Mm-hmm. We don't have much time, so we will go straight to the next presentation. That's Mark. I don't think it's a good idea to escape interoperability of data and services, but this is just a joke. So Peter, tell us about ESCAPE. And remember to unmute yourself. You are still
Okay,
your
so
presentation.
I'm here.
Yes. Perfect. Go ahead, please.
Okay, thank you very much. So it's really my pleasure to tell you about the ESCAPE project, which is one of the science clusters in the area of astronomy and particle physics, and in particular to highlight the interoperability of data and services. And I acknowledge a large number of my colleagues from the ESCAPE project in this talk. Next slide, please. So ESCAPE, as I said, it combines astronomy and particle physics, and there's a link to the ESFRIs. And those communities, you know, astronomy and particle physics, already have a lot of expertise in data stewardship, because data is so important in those two different domains. We bring together things such as the astronomy virtual observatory infrastructure, a framework of standards, and also the expertise from the high energy nuclear physics about exabyte data management and large scale distributed computing. And in the ESCAPE project, we build on a lot of things. There are already existing synergies between those research infrastructures that have overlapping competence and also interests. I think we have to recognize that in the future, you know, these communities are going to be one of the ones at the forefront of exascale data generation. And we've always been very close early adopters in terms of ICT and innovations. And so we are also moving into a system where those observatory and facility operations require not just, you know, local operation, but kind of global global access to the data, long-term curation and sustainability. So next slide, please. This is a bit more easy to explain because it's some pictures of our ESCAPE partners. We include particle physics partners such as the high luminosity LHC and a project, yes, which has the name of FAIR for Facility for Anti-Proton and Ion reactions. We also include the astronomy ESFRI such as the SKA, the extremely large telescope from ESO, gravitational wave detectors, Cherenkov telescope array, European Solar Telescope and radio astronomy telescopes like the SKA and the VLBI network. Next slide, please. So in ESCAPE, we bring these research infrastructures together with a program of work that is along the lines of the major topics that you see there. There's a data lake. It's a scalable, federated data infrastructure that enables a kind of distributed storage, but also connection to compute resources. There's a software repository, which is a major component of, you know, bringing the computing to the data and implementing a kind of community-based approach for sharing software. The Virtual Astronomical Observatory already has and builds on a set of interoperability standards and methods, and we bring that to a wider community, and we scale it for the next data volumes that are coming. In ESCAPE, and I'll highlight this theme a couple of times through the slides, is that we sort of combine those aspects through a science platform that's designed for open data analysis and brings together those different parts of the infrastructure. And Stephen Sargent has already highlighted some of the citizen science work that we were involved in earlier in the day. So next slide, please. So how do those things fit together? I mean, very generally, We are promoting, we're implementing and committing to open science with these ESFRI infrastructures and the partners that support the different parts of the data interoperability. So we can think of ESCAPE as a kind of EOSC cell that will connect to EOSC. The picture there shows the different parts that I just described, the science platform, the virtual observatory, the catalog, and the data lake infrastructure, with links to, things that we really need, the high performance computing, high throughput computing, the clouds, and support for networks such as through GNAT. And we envisage that those ESCAPE services will in part move into the EOSC exchange layer, and that there are also connections to the interoperability framework. There's also, we envisage to rely on the EOSC core for underpinning aspects such as the AAI. So next slide, please. I'll go quickly through some of those. The data lake, it's being tested already now with exchange of data between partners to test whether it's really feasible, and there's quite a few early successes in terms of moving data around, having consistent access to scalable, very large storage. Next slide, please. The software repository part has a flow diagram there, and which is about doing the things you need to do for a repository of software. And here we can envisage an EOSC API that connects a catalog to the EOSC, whether it be through the portal or through the mechanisms that enable the catalogs in EOSC. There's a bunch of deliverables which are highlighting some of those aspects about how you build the community foundation, how you train and bring people together, and how you can reward those scientists. So next slide, please. The part that I know best is on the astronomy virtual observatory framework, and here we're integrating the standards of an operational interoperability framework at an international level, where there are specific thematic services that really are in the line of open science. And we bring those standards based on the ESFRI needs into the EOSC context. And there's a use case that's even outlined in the SRIA about this. So EOSC is also envisaged to enable us to take the next steps, as I said, scaling for big data, connection to computing. There are other aspects that are about data stewardship and the next visions for very large archives. Next slide, please. But I wanted to highlight just one example of the technical interoperability, and that is with the IVA registry that has been brought into EOSC by using EUDAT B2Find. So in ESCAPE, we have identified that as a way to connect. We've checked the technical compatibility of the systems of the IVA VO resource and the B2Find model, both of them using OAI PMH. It's been implemented in B2Find, and it's currently harvested so that the endpoint is there. So, in terms of technical interoperability, our path forward is for this part is to understand the integration of EUDAT B2Find more generally at EOSC, and to make sure that that is supported. Next slide. The science platform at the ESCAPE level brings together the different services of ESCAPE. Okay, so the catalog services, the data access, the data and the compute services. We envisage those working together through different sorts of science platforms that can be implemented at the ESFRI, at research infrastructures more generally. It's us understanding how, in a robust way, in an operational way, to connect these types of data. Next slide, please. So very close to the end now. Here, connecting to EOSC, because we're at this stage now where the EOSC is really just coming into its first real implementations. This is a work in progress, and we see, as I said, ESCAPE connecting largely through the EOSC exchange, and we can map some of our work directly there, as well as in the interoperability framework where the existing standards should really be incorporated, because that's what's really working at the domain level in astronomy, for example. and it's based on 20 years of investment. To sort of promote this, we also have test science projects. I've talked about the technical side, but there's test science projects that really make sure that the system is going to do what the researchers need and bring their participation into EOSC. And next slide is just the summary that in ESCAPE, we are really working towards joining EOSC and bringing in the astronomy, astroparticle, and high energy nuclear physics communities. And with that, thank you very much.
Thank you, Mark. I appreciate the effort that all the participants are doing in maintaining the timing in the agenda. I'm actually the only one that are disrupting the agenda because you are doing it perfectly. Okay, so we are seeing 3 different clusters of scientists that are joining their efforts together and then bringing those efforts into EOSC. And we are seeing that from the environmental, geo-environmental point of view, and now from the astronomy and astrophysics particle thingy view. But we are seeing the same naming, the catalog, the data access. We are seeing that the same initiatives, maybe with not the same standards, but I believe we are talking the same language at least, and that's very, very good. But I don't want to penalize Laura.
I see that Bert Meerman has a question.
Ah, okay. Let's try it.
Yes, I had a question, but only if there's time. I'm not sure how pressed you're on time at this moment, Juan. I see there's...
We have a couple of minutes if we forget about the last part.
Okay, then
but
I have
just a couple of minutes.
Good. Then I have a short question for Mark. Mark, thanks very much. I wanted to ask you about the term data lake, because it gives to me the impression that you centralize the data and that you put a lot of data in the big store in the data warehouse. And what we see within the EOSC, more and more we see that we are driving towards an idea of federated data. Data should stay at the source under the control of the data owner, and we should start think more about data visiting rather than data concentration. So, have you thought about that?
Well, we certainly thought a lot about how we manage the exabyte scale data, and in fact, a distributed storage system, which the data lake maps onto, is one of those things that comes very strongly from the particle physics expertise in how you manage that type of data. Data lake, I agree, it's a bit of a catchphrase, and different people have different interpretations of really what it exactly means. It can mean, in some contexts, just a kind of distributed storage. I mean, you might say that's a cloud, really. But I don't want to get too much into the semantics of data lake, but rather that we're really following very practical lines of what's feasible in the places that really have the data. And they're not giving the data away to someone else to manage, but they are managing within this system. And it's a way of understanding how we can actually share data at the scale that's going to be necessary for the next year. So data lake is a concept that has many different sorts of interpretations and implementations, really. Yeah.
Okay. Thank you, Mark. Laura, you have the last remaining 10 minutes until we are expelled of this room. So all the remaining time is for you.
Thank you. I'm going to be faster, I hope. So, I'm Laura from Barcelona Supercomputing Center, and I will briefly describe WfExS development under the EOSC-Life project. Let's go to the next one, please. WfExS is a software component developed as a part of the demonstrator activities in the EOSC-Life project. The demonstrator projects represent a broad scope of life science domains and aims to make data, tools, and workflows available in the cloud for reuse by the scientific community. Specifically, WfExS was developed on demonstrator number 7, focused on the interconnection of infrastructures for handling sensitive human data, and WfExS is a high-level workflow execution service backend that can interpret research objects and execute the workflows contained within. In addition, WfExS is designed to facilitate secure and reproducible workflows executions with analysis deposited, for example, in EGA, to promote analysis, reproducibility, and replicability using the research objects. Next please, sorry. But what is a research object? Well, a research object or research object create is a method to describe data using a single linked data metadata document. The research object is based on schema.org annotations in JSON-LD, and the research objects aims to make the detailed metadata descriptions accessible and practical for use in different situations, from an individual researcher working with a data folder to an extensive sensitive data computational research environment. Sorry. Next, please. Here you can see some examples of items that couldn't be included in a research object. Data, workflows, scripts, results, metadata, etc. And we choose to use research objects in WfExS because research objects provide a machine readable mechanism to communicate a diverse set of digital objects and real-world resources, and aims to replace the traditional academics publications model on top of the linked data to share and publish a complete a structured archive of items that contribute to the research results, identifiers, provenance, relations, and annotations, for example. And in this case, we consider that it's important because all the research domains are increasingly replying to the computational analysis, and yet at this moment we have a reproducibility crisis because the analysis components are not sufficiently tracked, archived, and reported. Next slide, please. Putting the focus on the workflows, in this slide, you can see at the right the metadata describing a workflow execution as a workflow research object. That is a specialization of a research object for computational workflows with necessary documentation to run it. This is a basic example of a workflow research object document that have the workflow location, input data with their location to, the type of workflow, the repository containing the workflow location, and etc. And WfExS in the EOSC-Life scenario can create and consume workflow research objects and use it as an element of knowledge transfer between, for example, WfExS and Galaxy, providing information about executable workflows before and after the executions. Thus, WfExS can execute the workflow with a research object and can create a research object from information about the execution. Next slide, please. More specifically, WfExS development automates the following steps. In step 1, WfExS fetch and catch a workflow from a TRS-enabled WfExS Hub instance, which provides research objects. TRS-enabled service. Currently, we are tested with Dockster from an existing research objects and from a Git repository. In the step 2, WfExS identify the kind of workflow and fetch and set up all the necessary components to execute the workflow, like the workflow repository, set up the execution engine. Currently, we are working with Nextflow and CWL tool, and fetch the containers and fetch the inputs that are represented through an URL, for example, or from a query represented PID. In addition, for example, regarding the sensitive data from EGA at the start, in step 2, WfExS save all the elements fetched and cached inside a few encrypted directories using Crypt4GA standard keys to secure the execution of the workflows, so that the results can be safely moved outside the execution environment through insecure networks and storage. Next, in step 3, no, sorry. Thanks, Joan. Next, in the step 3, WfExS securely execute the workflow. In addition, before the execution, you can optionally create a research object that is consumable for WfHub with all the information about the workflow and the components needed to execute it. In fact, we are working on the development of this feature. And at the end, in the steps 4 and 5, WfExS collects the provenance data from the workflow execution and creates a research object containing the results of the analysis, for example, that in the future can be uploaded again to the workflow hub for reusability or into Nextflow and B2Share services. In fact, this is a future work too. And yes, this is the final moment. Next, yeah. And finally, well, that's all. And thank you for your attention. I think I have.
Laura, yeah. in the last minute, try to answer. If I give you a ESCAPE research object, can you do a workflow with it? Or a ENVRI-hub object?
If you have a research object, you can create a workflow.
I'm talking about, research objects coming from the other projects were presented before.
Yeah. Well, you can, in Workflow Hub, you know that we have research objects, and you can upload it, a workflow as a research object.
I understand it's a complicated question, but that's the key.
Yes.
That's the key thing. I mean, we are looking for interoperability between all these systems that has been presented today. And I like that we conclude with the workflows, because that is a reminder that we are not doing data access and data sharing for the fun of it. We are doing that to work with the data afterwards and swim in the data lake somehow and extract something from the data lake.
Yeah.
Okay. So you have still 2 minutes. Anyone wants to say final words? I have to say it has been fun. All presentations were really interesting. I believe the one about open knowledge, whatever, is the last step.
Open knowledge
after
maps.
The workflows, then you have this acknowledge and you do the publications and you start again with the search and you do new things. So that's my interpretation of it. We start with the research infrastructures like ENVRI, like maybe ESCAPE. Then we take this processing workflow thing, and then we publish something, and we have then the possibility to publish it and rediscover new knowledge and start again. That's the research cycle, I suppose. All right.
After those nice words, nobody dares to say anything anymore, Joan.
Sorry. So let's thank the 5 speakers. They did a great job. Thank you very much, everybody, and let's meet again on plenary in 20 seconds. Thanks.
Thank you.
Thank you.